Okay, so you'll notice then that we have been given some information about the various resistors or branches in this circuit, and some of the resistor values are unknown. And so what we've been asked to do is analyze the circuit using, all of the rules that we have, series circuit rules or series branch rules, parallel circuit rules or parallel branch rules, of course Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, and current division of voltage division if you so choose. So the list of quantities we're asked to find is I8, R9, R7, R6, V5, V3, R4, V1, R2, and the source voltage E. Now, we have then 9 resistors in a series parallel arrangement, and we have this VIR chart over here. No power in this particular question, but we have this VIR chart over here. And the idea is that the given information has been placed in the chart. Okay, so as an example, parallel rules tells us that if R8 and R9 are in parallel, they have the same voltage across them. So, one of the things that we can do is we can say that means that V8 and V9 are equal. And so in my VIR chart here, I also have V8 at 6 volts. Okay. Now, I7 at 2 amps, we know I7 divides in between these two resistors. We have V6. We have I5. Here, I guess we'll say that this is I4. It's shown here as 1 amp. But we know that in this branch, R3 and R4 are in series. So that means that I3 is also 1 amp. So we can put that in our chart over here. Okay, so I wonder what else we can conclude based on that. Probably nothing. Remember now that over here, right, there's R1 and R2 will both have the same current, but they won't have the same voltage drop, assuming that their values are different. So 10 volts, not the voltage drop across R1, and 10 volts, not E, right? And so keep that in mind. So basically now, what we want to do is we want to start analyzing circuit to come up with these quantities. And, we don't have the start here, but sometimes they're given in a suggested list of the order you find them in. So let's think about I8 first. Okay, so if I'm going to find the current through resistor 8, now the idea then is that, well, we already said that parallel rules tell us that if V8 is if R8 is in parallel with R9, then V8 is equal to V9, and that equals 6 volts. Well, that's good, because now I got 2 pieces of information about R8. And so that means that I can find I8 by Ohm's law. And so I8 is equal to V8 divided by R8. And so 6 volts over 4 ohms, and I8 equals 1.5 amps. And that was supposed to be decimal there. Now, so we should put that number in our VIR chart. Okay, so next then, let's think about, it says R9, the resistor value 9. And so if we're going to apply Ohm's law to it to find R, we need the current through it. we're going to write Kirchhoff's current at this node, and let me call it node A. So therefore, KCL at A, and the sum of the current that enters that node or junction, 7, is equal to the sum of the currents that leave. So 8 plus 9. Now 9 is the one we don't know. And so basically, if 2 amps comes down here, and we know that 1.5 goes this way, the rest of it goes through R9. And so R9 is equal to R7 subtract R8. And that gives us 2 amps subtract 1.5 amps R9 0.5 amps. So we write that in our table, and we'll go on now to say that by Ohm's law then, R9 is equal to V9 divided by R9. And so that is 6 volts divided by 0.5 amps, and R9 then is 12 ohms. So let's put that in our chart, 12 ohms. Okay, next thing we're asked to find is R7, and so I'm going to move up here now, and R7. Okay, so let's think about R7. Well, we know that if I mark this junction here as B, and this junction right here as C, then VBC is equal to V6 is equal to 20 volts. And, it don't matter what route it takes to get from B to C, the voltage will be 20. So across here, 20, across this one and this one, 20, right? So VBC is 20, no matter which way I'll get to go there. And so that's Kirchhoff's voltage law, really, because look, if I goes around the loop here, and if I'm going this way, this is a voltage rise. And if I'm going down here in the direction of assumed current, then these are going to be drops. And so these two drops equals this rise. Because if I'm going this way against R6, and my direction of assumed current is this way because the source pushes current this way, back this way, then, V6, if I'm going around this loop, is opposite in polarity to 7 and 8, or 7 and 9. And so KVL between B and C tells us that V6 is equal to V7 plus, and call this V8 or V9 because it don't matter because they're both the same. V9 equals 20 volts. And so therefore, I can say that V7 is equal to 20 volts subtract V6, or 20 volts subtract 6 volts equals 14 volts. And I should put that in my table. Now, every time I got two pieces of information about any one resistor in particular, I can apply Ohm's law, find the resistor value. So, if I do that, I can say now that R7 is equal to V7 divided by I7. And I7 is given on the diagram as 2 amps. So I have 14 volts divided by 2 amps. And that gives me 7 ohms. So I can put that in my chart, and you see now my chart's quickly getting filled up. So if we think about what we're asked to find next, it's R6. Okay, so R6. Now, so we called this here Junction B. And so for R6, let's think about writing KCL at Junction B. Right? So Kirchhoff's current law at B will say that the sum of the currents that enter, which is I5, is equal to the sum of the currents that leave, which are I6 and I7. Now, if we think about junction B here, right, we have 4 amps goes through R5 and goes into that junction. And that splits into 2 directions. Some of it goes through branch 6, some of it goes through this other branch here, contains 7, 8, 9. And we know 2 amps goes that way. So the remaining current goes this way. And the fact that they're equal, well, I mean, the combination of R7, 8, 9 is going to give us R6, same numeric value, I guess. And you can check that later, once we're done. But right now, it's I6 that we want, right? And so, from this KVL expression that we have here, I6 then is equal to I5 subtract I7. And so that current divides evenly, which again, you know, is the reason why I say the 2 resistances must be equal. 4 amps subtract 2 amps, and it looks like R's, but there's supposed to be A's there. So I6 then equals 2 amps. And now that I have 2 pieces of information about resistor 6, I can find the numeric value. Now I'm going to have to move this down, of course, to find, to do the calculation. R6 then is equal to V6 over I6. And remember we had 20 volts across R6. And now we know we got 2 amps that goes through there. And so R6 then 10 ohms. And let's put that 10 in our VIR chart here. Okay, so next thing then that we are asked to find is V5. Okay, so V5 is a relatively easy one because we're given the current, we're given the resistance. So V5 by Ohm's law is equal to I5 times R5. And again, that current on the diagram was 4 amps. R5 had a value of 5 ohms. And so again now we're seeing 20 volts across that resistor. And so you note that a lot of this can be done from the VIR chart, because you got your 4 and 5 here. You know the product of those is giving you the 20 volts, right? Okay, next thing we're asked to find is V3. So let's think about that for a minute. Okay, so we already agreed that if the current through this branch is 1 amp, more or less given for I4, then we know that I3 is also 1 amp. So then R3 comes from Ohm's law. And so let's go down here now and think about the fact that I3 is equal to I4 is equal to 1 amp. And so by Ohm's law then V3 is equal to I3 times R3, and we have 1 amp times 15 ohms, and that should have been a bracket there. So let me see if I can do a little bit of a better job with that one. Okay, so then V3 becomes 15 volts. And so we go over now and put that in our VIR chart. V3 here at 15. Now, so go back to our circuit now, and the next thing we're asked to find is R4. In order for us to find R4, we need 2 pieces of information about it. We only got one. Think about your VIR chart here, right? Okay, so analysis of the circuit now using KVL is going to be necessary, basically. And so let's think about this node right here. And so I got A, B, and C used. Let's call this one here now D. And this one down here, remember, is all of this stuff across here, all at the same voltage or same potential. And so this node here is still C. So we don't want to go giving it another label that's different from the one we already have. So now, VDC we got to think about, okay? And the voltage, VDC, is the same no matter what route we take to get there. And Kirchhoff's law, again, remember, kind of tells us that, right? VDC. And so, VDC equals R3 plus R4. Or it equals V3 plus V4. Or it equals V5 plus V6. Or it equals V5 plus V7 plus V9, right? Any of them. And so, VDC. Okay, so let's think about the fact that VDC on that diagram, and let me pull out a different color now, we'll do that with. VDC is equal to V3 plus V4. And we want V4, and we have V3. Remember V3, if we go up and pluck it out of our chart now, is 15. So this one is 15. Okay, so VDC is also equal to V5 plus V6. And we got those two values. Okay, so on our thing, D, V5, V6 gets us from D to C. Okay, so we got V6 at 20 volts was given. V5 we also calculated at 20 volts. So this is equal to 20 volts plus 20 volts, and that's 40 volts. So therefore, V4 now is equal to VDC subtract V3. And so we have 40 volts subtract 15 volts. And that means that V4 is 25 volts. So if I want to calculate R4, by Ohm's law, R4 is equal to V4 divided by I4. And we know both of those quantities now. And so we have 25 volts divided by 1 amp. And so that gives us R4 at 25 ohms. And so, the solution to this problem really, right, involves us going through the circuit step by step, using all the rules that we know and applying them to figure out the information that we've been asked for. And so up here in our table now, we can write in that V4 was found to be 25 volts, and R4 was found to be 25 ohms. Okay, so the next thing we're asked to find, we're getting to the end of this now, V1. Okay, so let's think about V1 here. And the idea now is that, well, KVL applies around this loop, but we don't know E either. We know it's our V2 now. And so let's think about current. Okay, and so we know the current that goes here has been given to us, really. We know the current that goes here. So Kirchhoff's current law at D is next. And I1, which of course is equal to IT over here, is equal to, by Kirchhoff's current law, the sum of I3 and I5. And that's Kirchhoff's current law at D. So that's the next thing now that we want to write, is Kirchhoff's current law at D. And so I'll start back here now. KCL at D. And if I do that, all right, what we're saying is that IT, which is the total current in the circuit, which flows through resistors 1 and resistors 2, because they are in series with the source, is equal to, now this branch resistance here, I'm going to call this I3 because that's the first resistor it goes to, but we know that I3 and I4 are the same, plus I5. And so I1 is right now what we're looking for, right? And so I3, remember, was 1 amp. I5 was 4 amps. So the total current in that circuit is 5 amps. Now, if I go back to my chart for just a sec, remember that we want to say now that I1 is 5, and that means IT is 5. That also means that I2 is 5. Now, if this current here is 5 amps, then that means that the total current that leaves the source is 5 amps. It divides here, 4 amps, 1 amp. Divides here, 2 amps, 2 amps. This 2 divides here. We had a 0.5 and a 1.5. And the 0.5 was I9, the 1.5 was 8. So we got 2 amps here, all right? That 2 amps combines with I6, got 4 amps going this way. That 4 amps combines with the 1 amp that came down to this branch. We got IT goes back that way at 5 amps. And that 5 amps that left the source will go back into the source, right? And so that's the way that, that's the way current division works. So 5 amps for all of these remaining currents. So right now, we've been asked to find V1. Well, we got R1, we got I1, so we got V1. So let's go back down here now and say that by Ohm's law then, V1 is equal to I1 or IT times R1. And V1 was 5 amps. And we'll multiply that by R1, which is 4 ohms. And so you'll notice that yet again, we have 20 volts across that resistor. V1 is equal to 20 volts. And of course, that's more or less coincidence, right? That's the way the circuit was designed. Not always the voltage drop across all resistors same. Of course, they're not all the same here, but a lot of them turn out to be 20, right? Okay, so then V1 here was 20 volts. Okay, the next thing we're asked to find is R2. So we've agreed now that there's 5 amps going through R2. And so I'm just going to say now that from that point of view, I2 is equal to IT is equal to 5 amps because it's in series with the source. And the idea is that, look, we could write Kirchhoff's current law for this part of node C right here, and we come up with 4 amps plus 1 amp is 5 amps and so on. We've agreed, I think, that that's true. Okay, so now if the voltage drop across R2 is given as 10 volts, then we have, by Ohm's law, R2 is equal to V2 divided by I2, and that gives us 10 volts over 5 amps equals 2 ohms for R2. Okay, back to our table. We'll soon have it done now. Oh, I've got my cursor. Last 2 ohms. So the last thing we have then is RT here, which we don't need, but it might be a good idea once you got out of resistors to go back and verify that you can combine the resistors using series parallel rules and come up with an RT value that makes Ohm's law agree right here. R equals VT divided by IT, just to verify that all of our calculations are correct. That wouldn't hurt. Okay, so the last thing we're asked to find is E, which of course is total V, right? And that's E, and we want to put that right here. Okay, so how are we going to find E? Well, we don't have RT, so we're not using Ohm's law. So it's Kirchhoff's voltage law that we're going to use. And, what we want to do now is apply Kirchhoff's voltage law around this loop right here. And if I can pick out a different color for that, let's go with this brown maybe here. And is it, or purple, is it? Around this loop right here. And so we're saying that E is equal to all of these voltages. Okay, so it's 1, 3, 4, and 2. And we know all of those voltages. We can plug them right at the table, right? And so let's go down here now and say that E is the last calculation that we want. And when we go around that loop, E is equal to V1 plus, in the order that you're given, I could V3 plus V4 plus V2. And so V1, 20 volts, right above this calculation here. V2 was given 10 volts. Oh, I'm sorry. V3 is the next one we want. And V3 is right here. 15 volts, or of course back in our VIR chart, they're all readily handy, let's say. V4, 25 volts. And as we said, of course, V2 given at 10 volts. So add up the 4 voltages, and E is equal to 70 volts. Now, after that, you'll find that now, once you have this 70 right here, the question is complete. Ohm's law will give you a value for RT, and then you can verify that we got all the resistor values now through series parallel reduction and verify that value right there. And you should be able to work out 70 divided by 5 and find out that that is 14 ohms right there. Not that we're asked for, right? E was the last one we're asked for. Okay.